Good morning, everyone. I am Huda Rashid from First MCA. Today, I am going to present my seminar on the topic requirement validation. Requirement validation is a crucial step in the software development process because it ensures that system we are building actually meets the user's needs. In this presentation, I'll explain what requirement validation is, why it is important, the technique used, challenges faced, and best practices followed in real-world projects. Okay, now let's move to introduction. Introduction to software requirements. To begin with, software requirements form the foundation of any software project. They define what the system should do and how it should perform. There are mainly two types of requirements: functional requirements and non-functional requirements. Functional requirements, which describes the feature and functions of the system, and non-functional requirements defines system qualities like performance, security, and reliability. It is important to note that poorly defined requirements are one of the main reasons for software failure. So, having clear and accurate requirements is essential for project success. Now, coming to the core concept, requirement validation is the process of checking whether the defined requirements truly reflect what the customer needs. In simple terms, it answers the question: are we building the right system? It is different from verification, which checks whether we are building the system correctly. Validation ensures that requirements are correct, complete, consistent, feasible, and unambiguous before development begins. This helps avoid costly errors later in the projects. Now let's move to why requirement validation matters. Requirement validation is important for several reasons. First, fixing errors in later stage of development is much more expensive compared to fixing them early. Next, secondly, it ensures that all stakeholders, including clients, developers, and testers, have a common understanding of the system. It also helps in reducing project risk by identifying issues early. Additionally, in some industries like healthcare or aviation, validation is required for legal and regulatory complaints. Okay, now this slide shows the difference between validation and verification. Validation focuses on building the right system, means it checks whether the system meets user needs. This customer focused and usually done before development. Now, on the other hand, verification focus on building the system rights. It means it checks whether the system is implemented correctly according to the specification. Both are important and complementary process in software development. Now, the requirement validation process. Requirement validation is not a one time activity, it is an iterative process. It starts with gathering requirements and followed by documentation. Then, a validation plan is credited. After that, validation activities like reviewing and testing are performed. Finally, once everything is verified and agreed upon, stakeholder sign off is obtained. This cycle may repeat until all requirements meet the desired quality standards. Now, techniques for requirement validation. There are several techniques used for requirement validation. Formal reviews and inspections involve experts carefully examining the requirements. Prototyping helps users visualize the system and provide feedback early. Test case generation ensures that requirements are testable and clear. Formal methods use mathematical models to check correctness and consistency, especially in critical systems. Tools used for requirement validation. To support validation, various tools are used in the industry. For example, IBM DOS or DOS Next. It's used for requirement management and traceability. Now, Jira and Confluence are commonly used in agile teams for tracking and collaboration. Rational Requisite Pro helps in linking requirement with testing. Cameo System Modeler supports model-based validation using system diagrams. Common issues and challenges. Despite its importance, requirement validation faces several challenges like ambiguity, incomplete specification, inconsistency, scope creep, time and resource pressure, traceability gaps, stakeholders availability, tool integration. Requirements can be ambiguous or incomplete, leading to misunderstanding. Time and resource constraints often limit proper validation. Stakeholders' availability is another issue, as experts may not always be available for reviews. There can be also inconsistencies, scope creep, and lack of proper traceability, which make validation more difficult. Best practices for effective validation. To improve validation, some best practices should be followed. Stakeholders should be involved early and continuously. Clear and measurable acceptance criteria must be defined. Maintaining a requirement traceability metrics helps track requirements throughout the project. Also, validation should be done iteratively rather than waiting until the end. Validation process workflow. This slide shows a structured workflow of the validation process. It starts with planning validation activities, followed by eliciting requirements through interviews and discussions. Then, requirements are analyzed and modeled to detect any conflicts. Finally, validation is performed using reviews and prototypes. This process is iterative, meaning it continues until all requirements are accurate and approved. Now let's move to advantages and limitations. Requirement validation has several advantages. It helps in early defect detection, improves stakeholder communication, reduces project risk, and ensures better software quality. However, it also has some limitations. It can be time consuming and requires stakeholder involvement. Some aspects, like non functional requirements, are difficult to validate completely. Also, achieving 100% completeness is almost impossible. Now, conclusion and future scope. To conclude, requirement validation is a critical step in ensuring that software system meet user expectation. It helps teams avoid building the wrong system and reduce costly errors. Looking at the future, technologies like AI and machine learning are being used to automate validation process. Continuous validation in agile and DevOps environments is also becoming more common. So, requirement validation will continue to evolve as systems become more complex. So, that's all. Thank you.